Hi students, today we are discussing a new chapter, polynomial. Before getting deep into this chapter, let's have a look into the definition of polynomial. Simply, polynomial is a mathematical expression of one or more algebraic terms such as a plus bx plus cx square. Polynomials have a great role in our daily life. They offer limited information. They can be used in more sophisticated analysis to retrieve more data. Now we are going into the topic, polynomials in one variable. Let us recall that a variable is denoted by a symbol that can take any real value such that x, y, z, etc. Consider an algebraic expression x square plus 2x. Such as a polynomial is called polynomials in one variable. There are some terms which is related to polynomial and they are, these terms can be explained with the help of polynomial x square plus 2x. The expressions x square and 2x are called the terms of the polynomial. Each term of the polynomial has a coefficient. So, in minus x cube plus 4x square plus x minus 2, the coefficient of x cube is minus 1 and the coefficient of x square is 4. Coefficient of x is 7 and minus 2 is the coefficient of x power 0. Everything consists of different types in it. Polynomials also have classification in it. If a polynomial having only two terms are called binomials. Example, p of x is equal to x plus 1. Whereas, if they contain only three terms means, then it is called trinomials. For example, p of x is equal to x plus x square plus 5. Next, the important term related to polynomial is its degree. Degree can be explained as the value of greatest exponent of any expression. Depending upon the degree, a polynomial is classified into a polynomial of 1 degree is called linear polynomial, and if it is 2, then it is called a quadratic polynomial, and if it is 3 means, then it is called cubic polynomial, and thus goes on. By using these concepts as states above, let's look into a problem. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. So, let p of x is equal to, take this, that is x plus 2, put minus 2 instead of x in the above equation. So, it changes as p of x is equal to x plus 2. Now, put minus 2 in the place of x. So, the equation becomes p of x is equal to p of minus 2 and p of minus 2 is equal to minus 2 plus 2, which is equal to 0. Now, put x is equal to 2. So, p of x is equal to x plus 2. Now, let us see how it becomes. P of 2 is equal to 2 plus 2, that is equal to 4. So, therefore, minus 2 is a 0 of the polynomial x plus 2, whereas 2 is not. Remainder theorem can be explained easily by a problem. Divide p of x by g of x, where p of x is equal to x plus 3x square minus 1 and g of x is equal to 1 minus x. This problem can be easily solved by the following steps. So, for first step, we should write the dividend p of x and divisor g of x in standard form. That is, p of x is equal to 3x square plus x minus 1 and g of x is equal to x plus 1. That is, arrange them in descending order of degrees. Now, the second step is, next is the division of first term of the dividend by the divisor. Here, it is as 3x square divided by x. Here we can cancel x from both numerator and denominator. So, we get 3x. This is the first term of the quotient. Now, the step 3 is the multiplication of the divisor by the first term of the quotient and subtract this product from the dividend. So, in this case, it is as multiply x plus 1 by 3x, which is equal to 3x into x plus 1, which is equal to 3x square plus 3x. Now, subtract the product from dividend. That is, subtract 3x square plus 3x from 3x square plus x minus 1 and gets a remainder as minus 2x minus 1. Now, the fourth step is, now the remainder is the new dividend and the divisor remains the same. Now, repeat again from step 2. Divide minus 2x with x and that gives the second time in the quotient, minus 2x divided by x. We get minus 2 as answer because we can cancel x from both numerator and denominator. Now, the fifth step is multiply the divisor by the second term of the quotient and then subtract and continue the process until getting 1 as the remainder. Let us have a look at the above process as whole. So now our chapter is over. What we have learned is polynomial. I hope all of you understood this lesson. We will reach you on the next chapter. Bye.